Hi guys, I'm Richard Sen. So in this video today we'll be discussing about how to do molecular docking, which is a very important part in drug designing, right? So where we have a protein and we have a target molecule, so that is a ligand which will be fitting inside the protein, and we analyze the docking studies, right? So in this video we will be discussing about an online server available for doing a molecular docking, which is exclusively free. Okay, so let us go into that. So you just go with mcule. I'll give it over here, and now this is the page for your molecular docking, and you find here it has a sign in button, right? You just click it. So I have already have a user ID and my password, so you can sign up here if you want to try the molecular docking. So I just sign in. Yeah, so this is the page which we are getting. So you can find many features which have been available here, and you have an online tutorial to learn how to do the molecular docking, right? So now here we find many tabs available. Here we are going to use the lead optimization. In that you just click one-click docking. Yeah, it's been loading. Yeah, so here we have that one-click docking page, right? So here you can find that the docking predicts the binding orientation and affinity of a ligand to a target. So we have the idea about the docking. So for that you just need a ligand, which you can draw it, or you can get the original structure of the compound by using these kind of extensions, right? You have mcule ID, you have smiles, you have cas number, IUPAC names, and ink and inky, right? So you can draw the molecule like ChemDraw, how you use it. And you have the docking over here where you can select the target or the file which you have. So you can find all the kinds of proteins which are available over here, right? So where to get this mcule ID? We have to need the structure, right? So for that we have an official page like the PubChem software. So the PubChem, the official site, will help you get the ligand, right? So here I go with the progesterone. Yeah, I can find it over here. Yeah, so you have the progesterone over here and you can see it, right? So I have the inch key, right? So I just copy it and I just paste it over here. So I paste it, yeah, then I go refine and draw, right? So now you have some stereochemical arrangements and everything, right? So now I have to select the target molecule, right? So where we get these kind of data, that all these kind of proteins which we need. So I need a protein named 1A28. That is the progesterone receptor which has been found through various researches, right? So now here we can find that it has a PDB extension over here. The PDB stands for the protein data bank, which are already aware in the first day of the program, right? So let us visit the official page of the PDB. Yeah, you can see rcsb.org, right? I just type my protein over here. That is the receptor for that progesterone ligand which I have been chosen, 1A28, right? See, I can find it over here. So in this part I can see I have the protein receptor, the progesterone receptor, and I have all the data which are available for it. I can view the structure in a 3D view. So we have many features which you are already aware of it, right? So here we get it. And if you see, you can find your progesterone molecule, see, has been fit into this cavity, right? So this is actually the docking process. So the docking study has a main role about the docking score, which we have been aware with the previous lecture, right? See, here you can find your progesterone ligand which has been bind into that protein cavity. So how this kind of docking is done? So the same molecular docking we are going to do. So we're going to take the progesterone receptor and place our progesterone ligand into this protein and do some docking studies. So let us do this molecular docking with the progesterone ligand and the target protein. Okay, so now I go to the one-click docking. I revert to that. So I have the molecule with me. Okay, I just click here the select target. If you have already downloaded, you can choose the upload files. Okay, so I have the PDB data bank over here, the protein data bank. So I have to just type that protein again, my target again, right? So 1A28. So see, I can find my progesterone receptor. So I just select it. Okay, so now I have that selected and I just give dock. Let's see what's happening. It's been loading over here. The docking is running now. Yeah. So in this part, if you see that the docking input 3D generation has failed, right? So what is the mistake? So we have to spend quite little time in reading the first two lines, right? The reason of the failure is that we could not generate a valid 3D conformer for your ligand, which is necessary to run the docking calculation. You can try to change the stereo configuration. That is, you eliminate the undefined and unknown bonds or draw the ligands in a different orientation. So you can find where the mistake is, right? So why the docking has failed? You have to change the stereo configuration. That is, you can eliminate the unknown bonds like putting the wedge dash bonds and everything. You have to remove that, or you draw the ligand in a different orientation. Okay, so let's revert back and we'll just try it out how it works. Oh, sorry. Yeah, so I have it here. So here you see that you have the different kind of bonds, the stereochemical arrangement. I just change it. Okay, I'll just remove this. I'll choose this and I join it. Then this one, then this one. Okay. Oh, sorry. Yeah, over here. So now I have it here. So I just have drawn it. Now let me try with the receptor is over here. Now I just click dock again. Let's see what happens this time. Yeah, it may take some minute, okay, because we are dealing not with some small molecules. It's some macro type of enzymes and everything, so we have to need some patience. And of course, a good internet connection, right? I think the docking has been finished. Yeah. See, now we have the docking scores are listed below. That you have the data clearly, you know, so you no need to have some sources to refer what is the docking score. So see, which has the more negative value indicates the higher binding affinity of the ligand to that target, right? See here, so among these, here we find some 4 docking scores, right? Minus 9.5, minus 9.0, again the same, and minus 8.9. So which is the least among this is the first one, the more negative value, which indicates the higher binding affinity. So I think we have to visualize it, right? So let us visualize. Okay, so now let us visualize the molecular docked thing which we have done now. So here you can see that this has the highest negative value. So more negative value will have higher affinity for binding, right? So let us visualize this. Yeah, so you can find how the ligand, that is our progesterone, has been fit properly into the cavity of the target, correct? So like these kind of orientations can be seen and the molecule is perfectly docked inside the protein. So you can find a list of all the amino acid residues which have been listed. So if I click on this, you'll be able to see all the amino acid residues and you can see the protein surface. You have to wait for a while for this. Yeah, so you see the protein surface which is been building. So how it is being, see that ligand is perfectly docked into this target. So you can download also the PDB file, and then you can import it in the Avogadro, and I think you know how to do it because we learned in the day one. Okay, so then let us see the other docking scores which has been displayed here. So I'll just give it. Okay, so here you find a little thing. So you can note that the ligand has moved a little away, right? So which you can notice over here. If I rotate it, you can see there it was in the center, but in this case, if you see, the ligand has come a little away out of that. It is coming out. Okay, so this is not a good sign of a perfect docking. Okay, so you will not prefer these kind of docking. Let's see the other one, the least. The other value, the least negative value. Yeah, so here also if you see, you can see the same way the molecule is not perfect at all. It's like coming out, so you draw that ligand will not fit properly, and some other day it can come out or without any sort of orientation. So it should perfectly fit at the center of your target. So that would be a good sign of a perfect docking. So you can similarly do all the features available over here. So hence we have seen about the progesterone receptor, so how it has been docked over here. So you can try for some more examples. So it's a free software. Okay, so one more thing which you have to notice over here is that you see there is no any stereochemical arrangements that have been kept over here. So while you draw using that one-click docking, the drawing area, you just give the normal skeletal structure and don't use some sort of stereochemistry, because you find that it is showing some error, your docking will be failed. So to have a successful docking, you just draw the structure as simple like this. Okay, so that's all. I think we have a good idea about the molecular docking. Thank you.